Heat transfer. People say it's one of the hardest ME classes. But let's break down the basics in 60 seconds. Conduction happens when heat moves through a solid material because of a temperature difference. Imagine heat spreading across a slab of metal. The main idea is Fourier's law. It tells you the heat flux, or how much heat flows through a material, depending on its thermal conductivity and the temperature gradient. Convection is different. This is heat transfer between a surface and a moving fluid, like air blowing over a hot plate. Newton's law of cooling describes it. It basically tells you how fast heat leaves the surface, depending on the temperature difference and a heat transfer coefficient. If there is no temperature difference, there is no convection. Radiation is special. Every surface at a finite temperature gives off energy as electromagnetic waves. And this works even without a medium. In fact, radiation is most efficient in a vacuum. The Stefan Boltzmann law gives the maximum possible emission from a perfect surface, called a black body. Real surfaces emit less, depending on their emissivity. Emissivity is just a correction factor between 0 and 1. A value of 1 means it is a perfect emitter. A value less than 1 means it is a real surface. Here is the important detail. Even if two surfaces are at the same temperature, they both radiate energy at each other. But since the rates are equal, the net heat transfer is 0. So overall, conduction is through solids and Fourier's law finds heat flux. Convection is between a surface and a moving fluid, and Newton's law of cooling finds how fast heat is carried away. Radiation is electromagnetic waves, and the Stefan Boltzmann law finds the upper limit of energy a surface can emit. That is just the introduction, but it shows why heat transfer is so important. These ideas explain how engines cool down, how buildings stay warm, even how the sun heats the earth. Out of the three modes, which one do you think is the hardest? Is it radiation? Drop your answer in the comments, and make sure to like and follow for more thermo and heat transfer explained easy.